Hello, this is Joe, and this is my Turing machine. This is about this is the second Turing machine, or second large redstone machine I've built. I built an 8-bit machine computer before this, and I'll show you a tour. So, and here's my headquarters, and the program's still running from the last time I ran it, so I'm going to press the reset button. And one thing I learned about these big machines is that it's really important to have a reset button, because if you ever have a problem, you need to be able to get it to the baseline, or you quite literally won't know where to start. And so a good thing about this Turing machine is that I built a bunch of lights to be able to tell me what the computer is doing. And for those who don't know, a Turing machine is an interaction, or a machine that causes an interaction between a tape and cards. And so the tape theoretically should be infinite, but in this case it's only 10 because I can't create an infinite tape in Minecraft. And so these lights represent the tape, and if the light is on, then that cell in the tape has a 1 in it. If that cell is, or if the light is off, then that cell has a 0. These lights represent what cell is currently being read. These use binary, and there's 4 of them, and so I technically could have 16 cells, but I chose to have only 10. And there's 6 cards. The 6 cards are over there. They use gold. But these lights represent what card's currently being read. Those 4 lights up there represent what part of the cycle the machine is in, and then the top represents, it turns on if the machine halts. And for those who don't know, halting in Turing machines it's really important. So these are the cards, and each card has a off part and an on part. And if the first thing the machine does is it reads a cell, and if that cell has a 0 in it, it'll read the back of one of these cards, and if it has a 1 in it, it'll read the front. The first punch represents whether after the machine reads the cell, it'll either put in a 1 if there's a gold block here, or it'll put in a 0 if it's not. This one will tells the machine whether it should look at after it reads that cell, whether it should read this next cell to the right or the next cell to the left. And the next 3 punches represent what card it reads next. And there's 6 cards, and also you need a code for halt, as the sign says, none equals halt. So if there's no punches there, the machine halts. And so there's room for 1 more card, but I chose not to have it. There's 6 of them. This back redstone part gets the signal from the cards out to the rest of the computer. This back part is kind of the meat of the computer, where it reads the cards. Of course, it's super messy, and I've learned since how to make this kind of thing neater. You want to evenly space things. You want to have similar things running at similar altitudes, and to have it this messy just makes it really hard to fix, and it looks really ugly. But here's the tape. These parts right here, this part right here, it repeats down the tape. It can hold 1 bit. I also used it in my 8-bit computer. It's really reliable. I like them a lot, and I copied this specific design from the internet, and it's one of the only specifics I really copied from the internet. Everything else is kind of handmade. There's 10 of them. This middle part reads the cells, reads the tape, and then these are actually these 4 things are the same individually as what was over there, but they are used to keep track of what cell is being read over there. And to be able to increase this number by 1 or decrease it by 1, we need to have an adder, and there's the adder. And the adder is the only other thing that I really looked up. Besides, of course, I had to learn how a Turing machine worked, and I looked that up. And in this mill stuff, a lot of it's the reset button, and a lot of it is just way more complicated than it needs to be. It looks like the machine is reset, so I can run it. Sorry. So what this program is going to do is it's basically just going to turn on all the lights. It'll start at the 0th cell. It'll read the first card and read the 0th, or input a 1 into the 0th cell. Then it'll move all the way right, inputting 1s in all these cells, and it'll move all the way left and input 1s in all these cells. And this one actually uses all the cards. It's going to read the first card, then the second card, then the third card, all the way to the sixth card. And then the sixth card will also use the front of the card. And then the sixth card is used to like input and to fill all of these. One cool thing about this machine is that it uses negative binary. These are represented by positive binary, and those are represented by negative binary. It's actually the first time I've ever used negative binary. For those who don't know, the Turing Machine it wasn't the machine that cracked the Enigma code. A lot of people think it is, but it really was just a conceptual thing that Alan Turing used to think about the halting problem. If you want to look that up, it's the halting problem. You'll probably catch like a number file video about it or a computer file video about it. It's pretty cool. But it was never actually supposed to be used by like an office or like a mathematician or anything like that. It's a conceptual thing. As you can see, it now got to the end of the tape, and now it's going to start moving its way back to the tape left, and eventually it'll kick into negative binary. But one reason I'm making a video of this Turing machine is because I have two other machines, an Enigma machine, the thing that the Nazis used to encrypt their messages, and I have that 8-bit computer I talked about. And the problem with those is that they're so big. I'm doing this on Xbox, and the Xbox starts to glitch. And this Turing machine is kind of small enough that it doesn't glitch. And maybe I need to move all this stuff onto a better computer, but I don't have a better computer. So, anyways, it's on the first card, or the first cell, I mean, and that's this one, and then I'll move on to the 0th cell, which is this one with the obsidian on it, and it'll kick into binary, and then once it kicks into binary, that's the last interesting thing that happens. So, alright, so now it's on 0, and it'll light them all up and be -1. So maybe I'll make videos about my other machines, but maybe not because they don't really work as well. So let's see it kick in a negative binary. Alright, negative binary, so that, for those who don't know, that represents -1, and this is a negative first cell, so it'll turn it on. And this machine technically could be used to add numbers, but I kind of chose a simpler program just to make the recording of this video simpler. Alright, well, that's the last interesting thing this thing does, so thank you for watching.